speed of the neutrons in order to increase the fission occurrence. These neutrons, they hit other atoms as well as they once again release some more neutrons, which the process goes on. These chain reactions can be controlled in a nuclear reactor, whereas the chain reaction that are there that takes place in an atomic bomb cannot be controlled. Now, let us see about the layout of a nuclear power plant. What are the various components that we have in a nuclear power plant? In a nuclear power plant, let us watch over the slide. The main components that are there in the nuclear power plant are nuclear reactor, heat exchanger, turbine, generator, condenser, and we have got pumps to circulate the coolant as well as to circulate the feed water. In addition, we have got a transformer and a circuit breaker. Transformer steps up the voltage in order to maintain the bus bar voltage, that is the grid voltage. Now, if we look at the operation of a nuclear power plant, we know that a nuclear reactor, it is similar to that of a furnace of a thermal power plant. A heat exchanger is similar to that of a boiler in a thermal power station. The reactions that take place, a lot of heat is generated. That heat is carried away by the coolant and is given to the water, which converts that into steam, and the steam it passes through the turbines and it flows. The turbine converts the heat energy into mechanical energy. The mechanical energy is given to the generator, which converts the mechanical energy into electrical energy. From thereby it is stepped up and sent to the grid. Now, let us observe the animation. So, whenever the reactions are taking place, the coolant is circulated within, coolant enters from the bottom and leaves to the top, whereas the coolant absorbs the heat that is generated in a nuclear reactor and it flows through the heat exchanger. In the heat exchanger, we have got water which absorbs the heat from the tubes and gets converted into steam. That steam that is generated is passed through the turbines and the steam enters the turbine at high velocity and pressure, gives away its energy to the turbine. Turbine generates mechanical energy, which is given to the generator. Steam, after giving up its energy, loses its velocity as well as pressure. The steam is passed on to the condenser. In the condenser, the steam is condensed back to water. This condensed water is once again fed into the heat exchanger as a feed water. This process is necessary because the water that is used is treated water and which is costly. Now, this is about the working of a nuclear power plant, that is the nuclear reactions that take place, they generate the heat is carried by the coolant that is flowing and the same heat is taken by the water in the heat exchanger. Steam is generated, steam it flows through the turbines and later it goes into the condenser and back as feed water into the heat exchanger. This is the cycle of a nuclear power plant. Now, let us talk in detail about the nuclear power plants. I want you to answer these two simple questions. The fuel used in nuclear power station is Is it coal, uranium, diesel oil or graphite? Which one is the right answer? The right answer would be uranium. Answer one more question. The purpose of a nuclear reactor is it burning the fuel at controlled rate, produce electrical power, produce mechanical energy or condense the steam? Electrical power is generated by the generator, mechanical energy is generated by the turbine, whereas the condensed steam is the steam is condensed in a condenser. The purpose of a nuclear reactor is to burn the fuel at a controlled rate. As we have talked, this is the major advantage that we get in a nuclear reactor, that is, we can control the reactions, isn't it? Now, let us talk about the nuclear reactor. We are aware of the fact that nuclear reactor is the heart of any nuclear power plant. So, let us go into the details of what is there in a nuclear reactor. In a nuclear reactor, we have the shield, pressure vessel, reflector, control rods as well as moderator. These are the important components of a nuclear reactor. Let us talk about each of them one by one. First of all, let us talk about the control rods. What does the name indicate? Control rods means it is controlling. What it is controlling? It is controlling the chain reactions that produce the heat energy. We are aware of the fact that the neutrons are the main cause for the chain reactions, isn't it? These neutrons, if they are absorbed, then there will not be any chain reactions. That is, the number of chain reactions that are taking place can be controlled by controlling the number of neutrons that are present in the reactor core, isn't it? Now, in order to absorb the neutrons, we employ a control rods. So, the control rods, they are the main things. They control the reactions that take place in a nuclear reactor. Okay. Now, let us see what the control rods are. The various control rods that are used are cadmium, boron, hafnium. These are the main things of a control rod. Now, let us talk about the next important thing, that is the moderator. The moderator, as we know that, as we have already seen in the case while talking about chain reactions, moderator reduces the speed of the neutrons. Moderator reduces the speed of the neutrons. This is done in order to see that the fission occurrence is more. The moderator, it reduces